This is a wind-up toy. In this lab, we will be calculating the speed of a wind-up toy. So for this lab, what we'll need is a measuring stick. We're going to use this meter stick. And you'll need a stopwatch. I'm just going to use the one on my phone. And you will need a wind-up toy. This might seem like a simple lab, just measuring how far the toy goes and measuring how long it takes that toy to go that far. But we need to be precise into how we record those measurements. So the first thing we need to do is we need to look at our measuring instrument. So we do have this measuring stick, this meter stick. What we need to do is we need to determine the resolution. So the resolution is the smallest interval that can be measured by that measuring instrument. So if we zoom in here, what that is that's the individual ticks for every one of these. So if you look at those big numbers are centimeters. Now those small ticks in between them divide the centimeters into 10. So the resolution for this meter stick is 1/10 of a centimeter. Now I also have to determine if there's an uncertainty digit. So what that means is that if I'm looking at an instrument, can I make an estimate to the next digit? So there are two kinds of measuring instruments, analog and digital. This measuring stick is an analog instrument, which means it has an uncertainty digit. So what that means is that if I'm measuring something and it falls in between those two lines, I can make an estimate to the next digit. So I should record all my distance measurements down to the 1/100th of a centimeter. Even if it's a 0, I still should record it. Now I need to look at the stopwatch. So if I look at the stopwatch, this is a digital stopwatch. Now if I'm looking at the stopwatch and I'm looking at the resolution of the stopwatch, it can measure down to the 1/100th of a second. Now this stopwatch is a digital stopwatch, which means it does not have an uncertainty digit. There's nothing for me to look at to make an estimate to the next digit. So when I record this, I want to record down to the 100th of a second. Even if it's a 0, I still want to record it. So the resolution and the uncertainty digit, if that instrument have one, will affect the significant figures of that measurement. And we're going to be taking that distance that the toy travels divided by the time, and our measurement can only be as accurate as our instrument with the lowest resolution. So that means that our answer when we're dividing has to have the number of significant figures as the number with the least amount of significant figures. So to do this, what I'm going to do is I'm going to measure how far this wind-up toy travels, and I'm going to time how long it takes to travel that distance. So what I've done here is I've put a little masking tape here. That's just going to be the start line, so I can line up the measuring stick right up next to it, right? And that's where I'm going to start the wind-up toy. And I do this because I might need to move the measuring stick out of the way because this toy doesn't travel in a straight line. It might bump up against the measuring stick, and I don't want that to happen. So I'm going to wind this toy up 10 times, and I'm going to hold the feet while I do that just so I don't lose any of that energy. And I want to wind it up the same amount of times every time because I'm going to run 3 trials and find the average just to reduce some of that random error. So I'm going to go ahead and do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I've wound it up 10 times. I'm just going to make sure the feet are just even with that masking tape and that measuring stick so I can measure how far it goes. So I'm going to get my stopwatch out. I'm just going to use the one on my phone, and I'm going to go on your mark, get set, go. So notice it's not going in a straight line, so we're not going to measure the curved path. What we're going to do is we are going to measure, well, how far it goes in this direction. So that's why I put that masking tape there, so I know where it has started. As you can see here, it's slowing down a little bit. And stop. All right, so now I have the time, and I can go ahead and line up this. There we go. And I'm going to measure it from the front of the foot because that's where it started, right? So I did that. All right, and I can tell about how far it went, and I know the time, how long it took to travel that distance. So I'll go ahead and run this 2 more times, and I'll go ahead and put my data up there that I got when I did this experiment, so we can calculate the speed of each trial and calculate the average speed. So to calculate the speed, I just take the distance divided by the time, and this is that equation that we can use for all of our trials. Now in some of these trials, when you take the distance divided by the time, you're going to get a lot of decimal points. Now here's how you decide where to round the decimal point. It has to do with the number of significant figures in each of the measurements. So because I'm dividing, my answer can only have the number of significant figures as which one of the numbers I was dividing, which one of those has the least amount of significant figures. So if one of those numbers that I'm dividing only has 3 significant figures and the other has 4, well, my answer has to have 3 significant figures. That is my measurement with the least amount of resolution. So once again, this is Wind Up Toy.